Hello, Year 9. Welcome to the start of this revision video, going through the pre-assessment, which some of you may have used as revision for your main test. So, quick video this is going to be, okay? Let's get my pen ready and start with shade the stated amounts of the following shape. So the reason the first one is quite a nice one is because we're shading in 5 out of every 9 squares. There are only 9 squares in here, so we're just shading 5 of them. 3, 4, 5. Compared to here, where we're shading in 3 of every 4 squares. However, there are a lot more than 4. Now, we could count the squares and work out how many 3/4 is. That's one way to do it, okay? So there are 20 squares here. 3/4 of 20 is 15. Colour in 15. Alternatively, find groups of 4 and colour in 3 out of those 4. So I can see that these are in columns with 4 squares in. So I'm going to shade 3 out of 4 in that column. It's not bad, well done, is it? The next column's also got 4 in, so I need 3 out of 4 of those. 3 out of 4 of those. You get the idea. And it works the same with the last one. The last shape is 3 out of 5. And again, each column has 5. So I'm going to shade out 3 out of 5 in each. All right, you can do a better job of shading, but 3 out of 5 in each column. Okay, find the missing numbers. So we're talking about equivalent fractions here. Fraction 2. So to change a fraction but keep it equivalent to the original, you can either times the top and bottom by the same or divide by the same. So going this way, we can see that 5 goes into 30 times 6. Or alternatively, if we're going the other way, the opposite of timesing by 6 is dividing by 6. Anyway, the missing number here, we'd need to times that by 6, and 1 times 6 is 6. Here, how many 3's go into 12? The answer is 4, so it's times 4. Do the same to the bottom. Whereas with these, we're working backwards. We're going, hang on a minute. How many 4's go into 24? It's 6, but going in this direction, I'm not wanting to times by 6, and I'm wanting to divide by 6. So the answer is 3. And the same here, going backwards. Again, it's a divide by 6 one. So the answer is 10. Okay, so you've got 2 where you're making them bigger, times in, and 2 where you're dividing. Writing down fractions in the simplest form. Okay, looking for numbers that this time we're dividing down, cancelling them down, making them as simple as we can, both in the 2 times table. So we'll divide them by 2. And again, both my numbers are in the 2 times table. So I'll divide them by 2. Alternatively, we could have gone straight to the answer if we divided by 4. But there's nothing wrong with dividing by 2. If you find half in numbers easier than dividing by 4, then you can divide by 2 again there. Whereas these, you're not going to divide by 2 here because they're not in the 2 times table, but they are in the 5 times table. So we'll divide them both by 5. Next. Question 4. Again, using equivalent fractions. They're not equivalent, right? With a common denominator, making the bottom numbers the same. So at the moment, the bottom numbers are 12. This one is 4, but I could make it 12 if I times this fraction by 3, top and bottom, to be 9 over 12. I could make this 12 by timesing this fraction by 2, so it becomes 10 over 12. And I could make this denominator 12 by timesing this fraction by 4, so it becomes 8 over 12. And my first fraction, the one with the biggest denominator, I'm leaving as 12, then putting them in order. This would be the smallest, second, third, and fourth, the biggest. Okay, so writing them in order then. On to fractions of amounts. All, look, this is your bread and butter. Okay, fractions of amounts, divide by the bottom, times by the top. You've got 25 is your answer there. 27 there. And just to show you what I would do if, workings out are important, and I haven't done them there, I would take the number and divide by the bottom, and then take the answer to that and times by the top. So divide by the bottom, and then times by the top. Adding and subtracting fractions. Okay, easy enough if the denominators are the same. Right, bit of a silly one there because you end up with 6 out of 6, which is a whole amount. So you could even write that as one whole 6 out of 6. But accept 6 out of 6 for now. Whereas this is 6 out of 12. There's no need to simplify these. There's no need to divide the top and bottom because you're not asked to do it. If you were asked to simplify it, then we would. Okay. Here, though, bottoms are not the same. A lot of this test is about making the bottoms, the denominators, the same. Here, our biggest is 8, and 4 goes into 8. So it might be worth timesing this by 2. But if you want, again, like we did on the last page, if you do that to the bottom, you've got to do that to the top. So this becomes 4 out of 8 plus 3 out of 8, which is 7 out of 8. And here, we'll be timesing these by 3, so that becomes 12, and that becomes 6. And when we take them away, we get 5 out of 12. Multiplying decimals, chaps, question 7. We can multiply the top, multiply the bottom. 4 over 12. But dividing, we're going to use keep, change, flip. I sometimes record a KFC, even though it's slightly out of order. It's KCF, right? So we're going to keep the 2 over 7 as it is. We're going to change the divide to a times and flip the second fraction. So we get 10 over 14. Find Abidosi. Question 8. I think a quarter, right, we should know. Okay. A half, we should know. However, when we're talking about, this is 4/10. 0.4 is 4/10. Okay. Some people will prefer, though, to go to the percentage first. Whereas this is 7 in the hundredths column, it's 7/100. But again, some people might rather go here. So I've already said this is 4/10 and this is 7/100. However, if you'd rather use the percentage to get the fraction, 40% means 40 out of 100, and 7% means 7 out of 100. So look, there, we've got that answer already. There, all that we've done there is simplified the 40 over 100 to get 4/10. So 40 over 100 is the same as 4 to 10. And actually, technically, we could simplify it by halving them again to 2 over 5. But any one of those fractions is okay, right? There's not, again, any one of those, I would give you the marks. Okay, let's go. Okay, well, easy enough. Change them to percentages. Right, so this is, again, this is the smallest, number 1. This is second because it's 25%. And this is third because it's 35%. Without the calculator, 10%. 10% is divided by 10. Whereas here, 1% is divided by 100. Okay, so 10% divided by 10, 1% divided by 100. 50%, we already know, we've seen above, the 50% is the same as a half, or 0.5. So that's another way of saying half of 12. So it is 6. So we'd be dividing by 2 for that one. And finally, in your non-calculator section of this, okay, I'm interested that Annie's score is 14 out of 20, and I'm trying to compare that with 81%. Now, to compare a fraction with a percentage, we kind of want that fraction to be out of 100. That's what percent means. So how many 20s go into 100? Well, it's 5, 20, 40, 60, 80, 100. So I need to times this fraction by 5. 5 times 14 is 70. So 70 out of 100 is the same as 70%. Okay, so Annie scored 70%, 14 out of 20, whereas Matt scored 81%. So who scored higher? Matt scored higher. Into the calculator section. If my time runs out, these are only allowed 15-minute videos here. If my time runs out, I'll do a second little mini video. Okay, with a calculator, I would always find 1%. We just said to find 1%, divide by 100. I would take the number and I would divide by 100. I would take the number and I would divide. You've got a calculator, so there's no reason not. Find 1%. However, the percent I want here is 15. So times that by 15. The percent I want here is 6. So I want times that by 6. And the percent I want here is 12.5. Now, I haven't got a calculator on me, but you can use those to do that, okay? Now, to increase a number by 12%, start with 100%. And to increase it by 12, we're adding 12% on. See if you remember this. So we're up to 112%, which as a decimal is 1.12. So we need to times that number by 1.12 to increase it by 12%. Or here, we're starting with 100, but this time, we're not adding 34 on, we're taking 34 away. So we go down to 66%, which is a decimal, is 0.66. So we're timesing the money this time by 0.66. And finally, again, you can put those in your calculator. So that's how you'd increase. Another way to do these, mind, is to find 12%, like we did above, divide by 100 times by 12, and then add it on. And here, find 34%, divide by 100 times by 34, but then take the answer away. Take it off the 245. That is the same thing. And finally, a repeated one, the hardest question, like a B grade question, okay? We need to increase this by 4%. There's 100%. We always start with 100%, but this time I'm adding on 4%. So I'm going up to 104%, which as a decimal is 1.04. However, I'm not increasing it by 4% once. I'm doing that per annum, which is another way of saying per year, and I'm doing it for 3 years. So I need to do this 3 times. And if you remember back to these couple of lessons we did, the quickest way to do that with a calculator is to put a little 3 there. Okay, so 15,000 times 1.04, which is a 4% increase, 3 times. Now, I have got a little bit of time left. So what if I wanted to do a 12% increase for 8 years? And the amount I put in was £6,000. Have a think about it. What would my sum be? And the correct answer is 6,000 times. That would increase, add that on to 100, you get 112%. As a decimal, that's 1.12. So I times by 1.12, and I'm doing it 8 times. Okay, guys, let me know in the comments beneath the video. I'll attach this to Teams. Let me know if there's anything else you want me to go over. If there's a question you want me to slow down, okay, because I appreciate that I've rushed this. But all the best. Guys, I just brought the last video to an end and thought, look, I got a bit more time to make this up to 15 minutes, so it might just be worth just picking some other things out that might be useful to us for tomorrow. So I just want to go into that percentage thing again, because I don't know if I explained it brilliantly, okay? To find 1%, you always divide by 100. So we just saw a question like, increase 76 by 12%. I want to show you 2 ways you can do it. I mentioned a way. Now, the way I just showed you was, I said, if ever you want to increase something, you start with 100% and you think of it as a bit added on. So if you're adding on 12%, if you're increasing by 12%, you're going up to 112%. You can then change that to a decimal and you can multiply the number that you're increasing by that decimal. Okay. However, if you'd prefer, you could go 76, divide by 100, which finds 1%, and times by 12. You could work out that way what 12% is, and then just add that answer onto 76, and you'll get the same answer. So either way, chaps, you can use what we call these decimal multipliers, 1.12, or you can go, no, I'll just find 12% and I'll add it on. And the same with decreasing, guys. Hopefully this makes a bit more sense now. It's a bit slowed down, okay? If I said decrease 76 by 12%, again, 2 ways to do it. You could start with 100, but take 12% off, therefore leaving yourself with 88%, which as a decimal is 0.88, and then just times the number you're given, this time by a number less than 1, times or equal, sorry, times 0.88, option 1. Alternatively, find 12%, exactly what we did above. Divide by 100, 1%, times 12, get the answer. But this time, we'd be taking that answer away, whatever that is, taking it away from 76, taking it off the 76.